So recording is started now. Okay. So we can continue. Okay. So it's .NET 6 already. Okay. Okay, I already have activity 6. I'll add the suffix t then. Okay. So yeah, and then I need to create a public class shape, and that will be public abstract class, right? Shape and an interface are printable. It doesn't matter if I create a separate file or the same, or I use the same one. Maybe for the abstract class interface we can use the same class, and well, that will be public interface. Oh, sorry, no, shape, but I'm printable. Printable. By the way, I just got the message that my connection is back. So should be good. Yeah, so then I create interface and printable, then two more classes to represent different shapes like rectangle and circle. Okay, so that would be public class rectangle and public class circle. And it is said they both should inherit from class shape. Yeah? So it means that we add the shape as the superclass for both of them. And yeah, and they both implement interface type printable. Oh, by the way, I guess that was not available in previous version, that you can press tab and it will suggest you the shortcuts for some typing. I guess that would be quite useful. All right, so they implement the interface, iPrintable, and okay, we need to change namespace. So they all should go to C# activity polymorphism. Okay, so that's done. So abstract class is created. This class can contain any variables and methods if you fit in addition to the following. So we have, we'll just use the following. We have public double area. So this would be area, and yeah. So the thing is that oh, by the way, hold on, no, okay, that's really fine. Yeah, and so here the thing is that okay, sorry, this is the all right, yeah, now I got why it is white for calculate 3. Okay, later on show, yeah, basically here is the thing. Yeah, I haven't realized when I said that you can change the access. I mean, you can change the access modifier, not the access modifier, but the returning type from white to double. But I mean, in this context, it's not needed. Yeah, because the thing is, yeah, so this would be public abstract and void calculate area. And so we'll see why. Calculate area. So, and this is void because we have protected setter here. So it means that this will set the value for area. So basically this may work as the setter. Yeah, so this method is actually, this method is actually used as the setter. Yeah, that's why it is void, because setters are defined as void. So that is why. And okay, so this is done. And that's why set is protected. So it means that array cannot be set from outside the class or the subclass of this class. So this is done. And the next one is calculate array. Okay, this is also done. Then under iPrintable, we need to add the void print. So just simply print. And this will print something. Then for the class rectangle, it needs to inherit from shape, and implement iPrintable. And here we need to define some attributes. So the attribute will be length. Yeah, keep on double. We can get a setter here. So same for width. Well, I guess temp is quite useful here in Visual Studio 2022. Okay, so and then we implement the constructor. And by the way, I can maybe skip setter. It's not. Maybe let's keep it. It's not too important at this point. So and under the constructor, I can define the length and the width. And then I can set the values for them. Again, by the way, it's really useful. Okay. So this one's done. Then we need to overwrite. Yeah, we need to overwrite calculate array, and here this would be correct. Yeah. So that was a little bit confusing for you that we need to use void here, but yeah, the thing is that here we can set the array from here. Okay. So we can set the array, and then we can get the array where we want. So and then this would be, so the area for rectangle is the length times the width. Okay. So this is done. Yeah, and by the way, so we simply call this method. It will set the value, and then we can get the area using this attribute, using this getter, which is public. Right, so this one is done. And then the last one, we need to implement the method print. So this should print something. What does it need to print? Display the area of the rectangle. Okay, so this will display the area. The area of the rectangle is, and here I can get the area from the method. Yeah, so this method should contain text which should identify that the rectangle class has been invoked. Contain text which should identify that the method of the text. Okay. Okay, so I guess this one should be correct. Okay, next one is circle. For circle, we need to add the attribute radius. Radius also with getters and setters. Here, then needs to find a constructor and provide the radius. Then we can set the radius. radius is set, then calculate the area. So remember for the circle, the area is 2 times, no, sorry, not 2, but this is for the perimeter, and for the area is P times R squared. So then calculate the area would be the mat DI, so that would be, we go to the quad system mat. Here we get the value for P. Times this radius. Yeah, we can square it, we can simply multiply twice. Okay. So this is done, and then we can print. I will copy paste from here. Yeah.
I suppose we're missing one square bracket, not?
Where? Which?
For the circle, yes. In the down, up the left square bracket is up. Is yes, this one, and down.
Good point. Yeah. Thank you. Yeah. Yeah. So thank you for this. And then yeah. So this is the area of circle. Circle is sorry. So we, in addition, we can also add the void calculates perimeter. And so this is just addition. And then I also do the same then for the perimeter. So then we can also do the same for perimeter. Alright. Void calculate perimeter. Then here I can set the perimeter. This would be 2 times, almost correct, be 2 times 1 plus. Because we simply need to count all the edges we have. Yeah, and we have two length edges and two width edges and two length edges. So then, and then here I can also add the addition. So let's say I use this one separator, I forgot. Or we can simply use them slash. And then not the area, but the perimeter is of the circle, or sorry, of the rectangle. And so we can move to the next one. And so here I can print the perimeter. Alright. And then the same here for the circle. Perimeter equals 2 times P times R times radius, and basically times R times P. So that in the system, mat PR. And then I can also copy paste this method here. perimeter of circle. Alright, so this one is implemented. Yeah, so we can create our own unit test class. So let's then the RSS is requested. So I will create new project. Test unit test class, this one. Six test. Yeah, test. And we can add a common solution and then I'll add it. Okay, it already exists. Let's do the test. Okay. That will be fine. Yeah. So and here I can create unit test class. So we'll this activity 6 test. Here I will implement the class. By the way, I can, yeah, I need to put reference to the project as we usually do. So then there will be activity 6. Let's do this. Oh, no, vice versa. 3. Okay, here we go. Here we go, and now we can run them. The program. Yeah, by the way, I can use namespace here. Oh. Namespace. Alright, and now I can write them test scripts for my class. So we need to test. Basically, let's test everything we have here. So first of all, let's say we test. Let's test one by one. So let's test. Let's test calculator for circle. So what I need to do, I can create the object. Yeah, by the way, what I will use for morphism, so it means that I will use shape class. I will use that would be circle, right? No, so we start with rectangle. Start with right. Oh no, I do circle, sorry. Circle, and then I create new circle. Let's now provide the radius, let it be 5. Just another number. It's 5, and now we can test the area. So to test the area, yeah, first of all, I need to print circle, and then I call the method calculate area, and then I check if area is correct. So I say I use r equals, so I compare the values. I compare the values I expect with the values I with the values received. So then I can calculate. Oh yeah, the interesting thing is that we have the pi here. So basically there are two options. I can provide the number. In addition, what I can also do, I can calculate directly here. So it means that that would be 5 times 5 times, so I can calculate directly here. This would also be the valid case since this is the constant number. So it's, yeah, I can already test this. Okay, so let's see if everything's fine. Let's do also can open the one, I think. And yeah, see that the test is passed. And my Visual Studio is going up. Then I need to call some programs maybe. Hope it would be better. Okay, so I see that the test is passed. So then I can proceed with the other test cases. So the next one would be calculate, let's say calculate perimeter. I can use the same number, or I can use another one. This won't be the issue. So, and then I can calculate perimeter here. So then maybe I'll proceed with the next methods, and then that one would be, the last one would be that we also check if print is correct. Yeah, I think maybe that was Wayne asked this question once about how can we test the output. Like how can we test the output? So yeah, ideally, I can. Yeah, we can test the output and we can check we can use the same approach I used here, right? Yeah, I think we used it here. So where was this? Yeah, so we use this one. So maybe I will copy paste the approach we used in our test case. So how we can test the calculating, but print test print so we have circle. So then I can maybe create a circle again. I'll calculate perimeter and reimpulse, and then I can get the writer, and then I can print the circle. By the way, so since this, again, we have the class, so it means that I can create the method. So because I will use this testing twice, so just not repeat the same code, I can simply call this method here. So how this would work? Then I will call the test, let's say test print. Here I can pass the object, so the object will be shape. Or I can also use printable, since I don't need shape, full shape. I can simply test printable. The object test, and I also need another parameter which will just test the output expected. The output expected. So that this means that I can simply copy paste this code here, and basically I can also directly put the object here. So yeah, now I can call this method. So this will be test, and this will be test print. So I pass circle here and I pass the string I expect. So let's check what is the string we expect to print. So maybe I will calculate it separately here. Just that it would be easier. I'll put expected. So then the array of the circle. The circle here. And then I can check the, maybe I can test the array separately, so that would be the array for the, yeah, maybe about the approach, I can calculate the array separately. So the array then would be 10 times system mass pi. So just to not rely on the values calculated from the class, I can rely on my own values. So then, so the parameter here, and then parameter will be 2 times 10 times mod pi. So here I can add the area. Here I can add the parameter calculated. And here I can check the output expected. Right. Yeah, circle is not null. But what's the problem here? Ah, yeah, hold on. Yeah, this is because it is the shape. So maybe I will adjust the task then. Or hold on. Or no, maybe in this particular case I will make it more interesting. I will cast it to printable. By the way, maybe I will also enhance this unit test here because we have more interesting things to test here. So let's then run the test. Right, test. So just do this. There's one test pass, but I have more tests. Yeah, okay, let's try again. Oh, by the way, yeah, because I have not marked them as test methods. I'm sorry. Yeah, if I don't mark them as the test methods, they will not run. Yeah, this makes sense. And this one is not a test method, this is just a helper method, which helps us to execute the logic. Let's test again. Okay, so we see that some test fails, and let's see where and why. So calculate parameters failed. And yeah, so this is, oh, hold on. So yeah, you can see that there is the issue here. And let's see where is the issue. So I tried to calculate parameter, but it didn't work. So let's see what was wrong here. What was wrong here? So the parameter is set. Okay. Why did it fail then? So that's the good question. That's a good question. Why did it fail? Ah, because yeah, my fault. Sorry. Because I compared with the array. Okay, so this one should be fixed now. Yeah, we also need to test the unit tests. Yeah. this may sound a little bit crazy, but also the unit tests need to be tested. Okay, so and the last one is, I guess there are some comparisons. The area of the circle is, okay, so yeah, here we can compare what we expect and what is needed. And yeah, I think that was the same issue as I had last time. This is related to the new line. Yeah. So I can use system environment new line instead of /n. Yes, /n is actually maybe not the safest option. So then I will use y start /n. Okay, so let's try again. Yeah, the same I will do here then as well. Oh, and yeah, by the way, I also have the space here, which is maybe not needed. So it is sensitive to all the spaces. So maybe I will exclude space here. Okay, let's run the test again. Okay, still something is wrong. Okay, so let's compare what are the differences here. So I have a space here and I have a space here. Oh, okay, maybe the new line here or what? Okay, so yeah, for the text comparisons, it is always very interesting. I think, yeah, so we need to spot where the differences are. So the area of the circle, okay. The area of the circle, yeah. So the values here are correct, and I also used I guess, hold on, I think I change it to the circle. Oh no, change to the rectangle, okay, so here's the issue. Oh no, I also changed to the circle. So where, let's check the value here. So what are the differences? Space here, okay, area is here, parameter is here, so everything is, hold on, maybe it needs new line to be at the ends, so this is the thing, right? So let's execute the test. Yeah, this was the issue. Now for the string comparison, please be careful. Please be careful, because there may be some spaces, or usually it's new line, and then it triggers the issue in the unit test. Okay, so this is done. Before we continue, I want to also test one more thing, two more things. So I can also test what check, let's say, circle implements a printable. So what I need to say, I need to check, I need to do some asserts. So assert is true. Then I check if circle is type printable. So I can do such check. Oh no, sorry, it's not circle. It's hold on. Type of. Okay. So this one. Then I can also check the same for the shape. Check, sorry, not for the shape, but for the rectangle. So we can test these two. Let's run the test and see if these two work. Okay, so the tests. Okay, so this is. Okay, so maybe for the type. That's interesting. True. Moment, so let's. Okay, so maybe for. Yeah, and here we can create the object of the circle and then check if it is printable. But the interesting thing is, so this is strange. Okay, there is one more option we can test. So now I can use get interfaces. Get interfaces. And then I can use the link syntax. So then let me use my link syntax as well. I'm using so what was this system link, right? Yeah. So then I can use any. And then I can so basically this so interfaces. The interface. And so I'll use interface, and then I will get the generic type of this. Yeah. Interface, and then I get the generic type definition, and then I check if it equals to the type of maybe not exactly generic, but a moment. Oh no, I'll get one moment. I don't want to generic type mission. Oh, I think I can use type of. Let's try this one. Oh no, I cannot. Well, it is already. Okay, so let's try this one. And I think I also need to add one more bracket, right? Okay, so let's check this one. Okay, so this one works. Yeah, it was a little bit more complicated than I expected, but still fine. So then just same for the rectangle. Yeah, it's actually a little bit long, but you can use, yeah, so basically I can use the type will get the interfaces, all the interfaces which are implemented by the current type, by the type I provided. And then we check if any. So this is wing syntax, yeah, I use formed expressions, and this checks if at least one of the interfaces is printable, printable. Okay. So, okay, and yeah, basically the same way we can do the test for the, so basically simply copy paste and change the tests we can do them for the rectangles. Yeah, I implement the test for circles, but for the rectangles they will be the same. Okay, do you have any questions? No?
Yeah, hello.
Yeah.
I have a question not regarding tests, the main file, program file, I mean. And I have a question. Does there is alternative regarding interface? Excuse me, inheritance. The question is now we have like the question is regarding iPrintable. Is possible option as an alternative that we give iPrintable inheritance to shape class? It means shape. That iPrintable,
Yes.
and does this means that this iPrintable automatically will be interface to rectangle and circle as well, and we don't have to mention it
we need to
or no?
mention that. We need to mention them, but then we can mention them as abstract. Yeah, we can mention them, but then we need to mention them as abstract.
So it's not like we can delete this I mean, it don't work that way if we give inheritance from shape to rectangle, for example, and it's automatically gives iPrintable as well together. It's not like that. Yeah?
It automatically gives a printable for the rectangle then. So in this case, I don't need to.
If we, yeah, okay.
In this case, I don't need to.
To make.
Yeah, in this case, the only difference is that I need, instead of using void, instead of implementing, I need to override it.
Okay.
Override. So this will be the difference.
And to add, can you show me once more? You added, I think, in the shape class something.
So in this case, that will work. In the shape class, yeah. So what is the shape
you
class?
Added public abstract void print.
Yes, because interfaces, they require the methods to be implemented. Yeah, so because for if I add the interface to the class, then I need to implement all the methods from these interfaces I added. That's why, and if I use the abstract class instead of implementing the method, I can define it as abstract. So this would be the alternative to implementing. And this means that automatically that rectangle, basically all the shapes, they are automatically printable.
Okay, thank you.
Yeah. But yeah, so in this case, the idea is that we want to make it in the way that not all the shapes are printable. So this is the point. But yeah, so if you want to merge the interface and the abstract class, then you need to then define. So that would be something similar as override in the in non-abstract classes, but this is then the abstract. You define it, and that means that you don't write the implementation here. So, but yeah, good question. So, do you have any other questions, anyone? This particular class, we can add more unit tests if needed. So just up to us to test whatever we want. Yeah, we can make multiple. We can also make multiple tests on the same method. Yeah, so if needed, I can also make multiple tests with the different numbers. So that would also be the valid case. So for example here. And so it's not mandatory that I need to add only one test case for each test method. I can make multiple test cases. Okay, so if there are no questions, then we can move on to the next one. The next one is activity 7. This one is activity 7. So again, I create new project. Class library. Solution. So I need to create a new abstract test was for the sections. Create abstract class for data. Structured is designed to hold the deal iCard object. For iCards, I think we already had them, right? Yeah, we can use iCard then from the previous tasks. And then for moments, I will then paste it here. This from previous. Well, I can add that to activity. Now I need to forget. Here. Okay, so I need to declare an abstract class card deck. Card deck. Abstract. Deck under the namespace we define here. And so yeah, most of the input is up to us. The following methods need to be declared. So we start with the, also let's use namespace system. So and then we can, so yeah, first need to initialize deck abstract, void initialize deck. Okay, and that should be already in subclass. This is all the abstract methods. Okay, the next one would be public codec. So this is not the, this is the constructor, parameterized constructor. Okay, and that can hold some default numbers of cards. Okay. So that can hold some default methods of the cards. The constructor will call the method to initialize deck to populate the deck. Yes, so I can call the method initialize deck from here. And so even despite it's defined as abstract, the idea is that the constructor will be called at the moment when we have the real class. Yeah, because remember that for the abstract classes we cannot create the objects. Yeah, so it means that abstract class will be populated. I'm sorry, not populated, but it will be extended in the subclass, which is the real class, and then this real class should override all the abstract methods then. And that means that at the point when constructor is called, abstract method will be initialized, will be implemented for the subclass. Yeah. So that's why I can do it. And yeah. So then, as for the structure, to hold the cards, try to use one of the structure that you created before. So we can use array stack or So maybe let's use array stack. Why not? Or maybe I'll use array store. What we used before. Oh, yeah, by the way, I can simply, so since you remember that we implemented array store here, so I can simply add the reference to this demo project. Yeah, right. So that was from the last session. So that is the 6th of December. Okay. So, and here I can store the cards. Okay. Yeah, so I can use array store here. Oh, hold on. So what was the namespace I need to use them? So, excuse me. So I'll use this namespace. Then should have a array store. So the type would be iCard. iCards. And then I can create it already here. Alright. So then I have one card deck. Then this will be the number. This number. And this is the constructor which creates the deck of cards. Okay, making code provides number of cards. Oh yeah, by the way, for the array store, I can create additional constructor, which will define default capacity. So let's do it. So that will be, let's say, default size. So I think that would be fine. Yeah, I can use then size defined here. Then I have the capacity and the size. Okay, that should be enough. We have it. So. Okay, so now I can initialize that list number. Yeah, by the way, then I don't need here. Then I got, sorry, I need to define it still, but let's say that we protect it. So this will be protected because I want to use it here and in the subclass. So then I define, then initialize the deck of cards as requested. And let's see, yeah, structure also must call initialize deck. So what's the hold on, why does not should take two. Oh, yeah, I guess there should be the issue here. I think yeah, so 1 moment. Oh, no, yeah, I got it. That is we then also need to define this constructor. Yeah, because at this point there is no issue because the superclass has unparameterized constructor, so it means that the current class will automatically call it, the constructor without the parameter. So it means that if we want to add the constructor with the parameters, I need to add it separately. So do it this way, which is simply initial. Okay, so this is done. So we have this card that was the number. Okay, and we also need to initialize. So let's write this one as warning. Let's this one, for example. Okay, so this is fine. Now let's proceed next. So we defined, so then this would, the next one would be public iCard get card. Okay. So this removes and returns random card from the deck. So random. So if and yeah, if the deck is known, then we support this known. Then we return if the deck is empty or the deck is, I mean, the deck should not be empty. So maybe I'll create, or maybe I'll do it this way. I will create the cards without one of these sides. And yeah, by the way, I also then need to redefine the constructor without the size. Okay, so it should not be null. So I say the count. So yeah, if count as null, then I return null. Yeah, if deck is empty. Otherwise, I proceed with the logic, and then I get the random card. So we need to get the random number. So random number in the range from 0 to the size -1. So what does it mean? It means that we need to get the random number. So I can use mat random. So what is this? Sorry, that's not random. Random, yeah, this one. Random and two. Sorry, I forgot about this. Quickly check. Number. So it was random. Let's quickly check. Oh no, that was simple random. Okay. So BMD and I create a random object. Yeah, that was correct. And then I get this less than specified maximum. Oh yeah, so then I can simply use next. And then I will, so again, it should be, yeah, which is from 0 to less than the count. Okay, so we can simply use the count position. Then I get the random deck from the count. Oh yeah, here okay, so here I don't have the by index, so we need to implement that. For the array story, I forgot to do it. But, no, we don't need it, sorry. Yeah, that's correct. Sorry, and then we simply use this approach and simply use indexer. Alright, so I think this should be correct. So yeah, okay, we use class random. And the next one is that we get card by providing the iCard. So we overload this method. Okay, and so yeah, this removes and returns the card. So okay, so if there's no matching card, yeah, by the way, so we got index 2, so that would be index position. So we use this card back, index of the card. Okay. Yeah, by the way, it is there's not a structure, which is -1. That means that it is not a structure. So if position equals a raised to or of the structure, we can use constant this way. Yeah? So here you can see how we normally use the constants. Yeah, so we access them directly from the class. You see that I don't use -1 or just some other hard codes. I use this constant directly. And so this is how we should use the constants. Not -1, not something else, directly from the class. Then I return it's not the structure, else I return so else I need to remove the card, or I can simply remove add, that would be faster. And then I return the card. Okay, so I can do this, but this is not okay. Okay, this was a little bit crazy, but okay. Okay, so this is done. This is done. So this point is done. Let's go to the next one. Next one is put card. Okay. So that's another bracket, right? Yeah. So next one is public put card. This would count here. So this adds specific card into the list and returns true. So if the argument is null, means that the card is right. So if the card is null, then we return, then we throw the exception. So we throw the exception this way, and we have no exception. Else I proceed. And yeah, by the way, if we throw the exception, we don't need to return any value. Yeah, so this is such a specific case. Yeah, we don't do it. So yeah, and then we add the card. This card, well, yeah, I can directly stop and returns the position. Oh, by the way, okay. Oh, it's both, sorry. So in this case, then we return true. Okay. Yeah, by the way, it means that this will never return false, right? You see, because it has two options. If one option is that it returns true, and another option is that it throws the exception. Yeah. So this is such a specific case. Okay, yeah, then it's done, and the last one is that we implement the method public integer card count. And so this simply return the current number of the cards in deck. So then I can simply temp. Alright. So okay, now we're finished with card deck class. Do you have any questions? Alright, then we can have 10 minutes break now maybe, and then we proceed with the further tasks here. So let's meet at 7:15. Okay, so we can continue. We can continue. Okay, yeah, that should be fine. That should be fine. Ah, yeah. So one more thing, yeah, we can declare like code as nullable, so we need to add an exclamation mark, question mark. So question mark will give us the opportunity to return that. Yeah. So it's just an option. Okay, so this is done. Then next thing, the abstract class deck cannot be instantiated, so create another class, simple deck. So we need to create another class that will be like simple deck. Which will also have a class which will implement the callback and need to initialize, need to override initialize deck, write up R, initialize deck, need to initialize it, and yeah, so to hold cards, define private instantiate simple cards, and for a moment hold the cards. Okay, so I can, okay, so this will be the card holder, so I need to stash it from activity 5. Okay, so let's do this. Simple parts. Oh, okay. So one moment. Let me check what was this. It's 55. Okay, so see it. Maybe like that here. Parts. Here we go. And then I can hold cards here. So then I'll hold the simple part here. Private simple part here. Array. Simple cards. And so yeah. It's that's funny, okay. And provide a property cards to return this array. So moment with the property cards. Moment. So it doesn't mean provide property cards to return this. Okay, I got it. Sorry. Yeah. So this means that we add the element to the class, which is public cards. Oh, I think so. That is very that's meant this way. Okay. To return. Okay, let's also say this. Oh no, sorry. I also need to set this. Okay, and we need to initialize this. So one moment, it's not initialized. Yeah, okay, and abstracts to hold the cards in front. Okay, this is done. Okay. So. Okay, yeah, so here I think we need to then cards. And let's say we have how many cards can I have? One moment. Okay, so since the cards is protected, then I think I can initialize it with the maximal size. That will be the count plus the capacity of the cards, maybe. Okay, so we done it here. So I think this is what is meant. Yeah. So this will be fine. Okay, so and yeah, then I can do test now. So I can add a new project, and then this will be for the unit tests. NET-7 tests. Section. And time to put reference. And reference. Maybe some points are missed, but we can fix them. Interesting. So this is activities. Still, we don't need the unit tests, so we delete it. And we add the one provided. Do this one. And so maybe something is wrong, but let's test. Let's test. By the way. Oh, yeah, hold on. We need to represent that the simple deck was. One moment. Let's declare. So, no, so it should be card count. Hold on. Okay, so for this one, then instead of creating the method, we can use getter and setter. Sorry, getter we can use. So here we can simply use get. And we can return the value. So we don't need to define it as the method, because initially I thought we need to define it as a method. We don't need it. Right? Okay. So this is good. This is the first thing to test. Yes, now it is fixed. And okay, another one is the cards. Okay, it should be public. I define it as. I think I define it as protected. Or no, sorry, I define it as private. So I need to fix this. Simple cards. No, sorry, not simple card, but a simple deck. I define it as public, as private. My fault, sorry. Okay, should be better now. Okay, the compiler does not understand that this will always be executed during the compilation. Okay, so do we have any other errors here? No. Okay, so let's run. We may have some issues, but let's extend them together. Oops. Okay, we have some errors, that's fine. And of course, maybe also some programs because it seems that my computer doesn't like it. Okay, so it should be better now. Let's open it again. Oh, okay, let's make it. Just my screen going crazy sometimes. So it's better. So yeah. Oh no, this is different activity. Sorry, different test. Sorry, not this test. This is different one. Okay, okay. So let's run this one. Should be better now. Okay, it runs all the possible tests. It's fine. So we have test method not draw expected exception argument. No exception. Okay, so this is this one. That card. A moment. Was it supposed to draw the exception here? Actually strange, but one moment. So get card. Actually, it was not. It says that it expects to throw the exception, but actually that's not mentioned in the task, right? Yeah, so it was not mentioned. So okay, then maybe that is issue in the put card. We should have the exception, but okay, we can do it. Why not? We can throw this exception. So then instead of returning, I can throw the exception. So why not send it over for me? Let's run the test, see if this issue is clear now. Okay, this issue is clear, and now let's see what's wrong with the main test method. Yeah, so we see that we have actually only 2 test methods, but this, okay, the graphics goes crazy. Okay, so maybe cause some more programs and hope it will be better. Let's okay, hope it's better now. Okay, so we have a search tail at line 47. So let's see what the issue is at line 47. Line 47. Okay, we have this deal count. And it should be greater than 2. Okay, so we can test this particular case. So it means that the deal count, what this actually means that, okay, it goes through the cards and checks. Okay, if the card was a random card, then increments the deal count. Okay, but let's then put the breakpoint and see the output here. Okay, so this is the exceptions file. And now we are here. So we see it initializes the codec. Oh, sorry, not the card was the card counter. What was that? Okay, I need to try it again. Why the step overfilled here? Let's try again. Sorry. Let's run the test. Okay, go step over. Go to the next line. Okay, so here. Okay, the count is 0. This is the problem. Okay. And okay, and it looks like simple tag. Okay. So we need to. How many cards should we have there? Let's maybe add 52 cards, maybe. And that was the issue here. Yeah, the problem here is that the card count was small. So I delete the breakpoints for now. Okay. So I'm looking at the task here. Okay, so let's say the capacity. One moment. So there's something wrong with the tests. Because okay, so here is the simple desk initialized. So I created simple deck, sorry, and then it gets the card. But then the thing is that the count is much more smaller than expected. Okay. But okay, yes, so then let's say we use the capacity. Let's say we make capacity 52, maybe. Okay, and but yeah, the thing is that it still wants the card count to be added here. So the card count, it's actually taken from the card. From the cards. One moment. I think there are some points missed in this. So because in unit test I don't see the unit test adds any card to the. So yeah, this is the thing I'm worrying about. So yeah, I think there's. Okay, for me it's the problem that it. Okay, that's maybe. No. Well, it's card count. Card count is 0. So this is the thing. Because I don't miss anything in this task. Because we haven't had any cards. to the I mean the problem we see in the we can also check the unit tests. See that we don't add any cards. I mean we can do it for the test cases. The test case or not. So I can implement a simple cardec. So I can add some cards there. Cards add. So simple card, because simple card is not used in the unit test, right? Yeah, it's not used here. So okay, then I can add the card by myself. Maybe let's add some cards here. So maybe something like this here. This may look crazy, but why not? And then yeah, here then I can stick with the approach of card. Okay, let's check now. Okay, now we have all the test points. Yeah, so this was just up to us to implement the initialization of the codec. Okay, so this task is done. Do you have any questions about it? So this is, yeah, this was most for the improvising, yeah, because we have lots of things to add from ourselves. I mean, the type of the collection, the initialization of the simple DAC. Yeah, so this was up to us to initialize. Up to us. Yeah. So okay, then this test activity 7 then is done. And we can move to the last activity we have. Here is the activity 9, activity 8. Okay, so activity 8. Activity 8. Then we'll add it to the current solution then. Okay, this is say more real task here with the customer info. This is what we usually have in the real projects. And yeah, so oh sorry, I created a test. Okay, but we'll still need the unit test. Maybe not now, but maybe I'll keep this and create a separate project now. To call the implementation maybe. Okay, so I created it, so I can support that should be fine. Yeah, and then we start. So first of all, I need to create the class customer information, and also need to add the namespace. Also use the system as usually. Okay, so this is done. And the implementation is up to us, as usually, but it should contain the following variables and methods. So first of all, it should be integer ID. Then it should be the string name. address. Public string address, sorry. So it's getters and setters as always. And email. Some all the main information about the customer. Semicolon. And then we to declare the constructor. Integer d string name, string address, and string email. And then I can set all these values here. I can use tab. Yeah, it's quite easy way to write the code. Actually, I like it. To change. Remember, for the parameters we use lowercase letters. Okay, it's done here. So the constructor is created. Then next one would be that we implement custom collection class called customer info collection. Under the namespace collections. So in this case, okay, this will be the same namespace, right? Yeah. So then I can create this class again. Class customer info collection. There's my collection then. And so yeah, so here I need to create the methods. Let's say add, like integer add customer info. So in theory I can make my life easier. I can use, let's say, maybe linked list or something else. So just because in practice we usually use the existing collection, so maybe at this point I will allow myself to create system collections generic. So maybe I will use them linked list. So let's say I declare the linked list. So I'll just simply make my life easier. And I will initialize it right at the beginning. Okay, so here I will add, and then I will add last customer info. And I want to return the index. Oh, hold on, yeah, for this one, yeah, we have the value. Oh no, hold on, I can do the following thing. I can return, then this, I access the collection. So then I use index. No, hold on. Maybe let's use not linked list but list. So that would be better, I think. Then okay, let me maybe again add last first It will be at, yeah, and this, okay, this is the void. Oh yeah, sorry, by the way. No, sorry. I can simply get the last index I have. So if I add last, what does it mean? It means that it will add the element at the last position, right? So yeah, this is quite simple. So it simply means that I need to get the size, right? Sorry, the size. So what's the size? Moment. Sorry, what's the size? Uncount. So yeah, because it's usually different. It's semantic size. Yeah, so then I return count -1. Yeah, because if I add at last position, it means that I added at the position count -1. So yeah, then I can do this one. Okay, add customer info. Let's add, and if so I can check if it's null. So then I throw the exception. Arguments, no exception. Okay, this is none. So if the input argument is not otherwise, we add to the collection. And yeah, and if the object is already in collection, then we need to return -1. So okay, in this case we can check if the object is already in collection. So then it means that we need to check it. So if customer infos, sorry, not customer info, customer infos, we check. So not check, but sorry, not, yeah, find. We can use find. We can use find, and then we check if it is here. So if find not equals null, then we return -1, yeah, as requested. So next one is insert. So insert will ask the position we want to insert at. So that we customer void, public void, insert, and the customer position and the customer information. So and here I should add the collection. And okay, so it asks add after. Yeah, for linked list, yeah, the thing is that for linked list, that's maybe that's complicated. So to add up. Okay, so maybe let's use the list instead of linked list. Yeah, I'm sorry, but it's it. Okay, then I added that as position instead of find, I can use, yeah, because linked lists and lists, they have different methods. Yeah, so then I can use contains instead of find. So that I can also, the syntax is different a little bit. Okay, and then here I can insert. Yeah, basically I can use same method. This with position and customer info to add. So then there are some exceptions. As usually, if the argument is null, then I do the same as here. So this is done. And argument out of range if the index set is less than 0. So if position is less than 0, then we throw argument out of range exception. Alright, this is done. Okay, if the object to be set already, transfer should do nothing. And so do nothing, so it means that I still need to check if it contains. And so then I simply, so in this case, do nothing means that I call the return for insert for void. Yeah. If I call return for void, it means that I do nothing. This means nothing. Okay, this is done. Next one is remove. Void remove customer info, same customer info, and then yeah, then basically I can use what is the advice here. Yeah, so in this case I need to again throw the exception argument null if it's null. So basically I can use the advice here, throw new argument, no exception. Alright, so it's done. The input argument is no. Okay, next one is contains. That's very well point, but simple Boolean. Again, I have customer info. So in theory, yeah, in theory, this class could be extended from the. I'm not sure if list is final. So if it is sealed, not so. Let's quickly check. No, in theory we could then extend from the list. It would also be an option, but okay. Let's send it this way. So it's not something really different. So then I check if this contains. So again, I check if customer info is not wrong. Sorry, hold on. There's no title exception, so the same check as usually. So and then I check simply I can return the result of contains method. Yes, so this one is done as well. So the next one is index of integer index of customer info. So again, the same as before. Right. And so then I can return customer index of, and I think it also returns -1 if it returns, yeah. So yeah, it returns -1 yeah, because simply in programming for for most of the cases. When we read the tables, when we fetch the data from some kind of collection database or whatever it is, then we usually get -1 if the data is not found. Yeah. So this is what we usually have by default. And okay, the last one is the indexer we need to implement. So let's implement indexer customer info. Index and get index property. So it should get customer information provided by index. This, and I will return then customer info is given by index. Sorry, was get by index was no, so that's fine. Oh no, hold on, I think I can do the same, right? Yeah, I can do the same. Yeah, so here I can just simply extend these two parts. I guess that would be the same. Okay, so yeah, and they should get or set. Okay, so it also should set. Okay, for set, this may be more tricky, but then we can simply call this insert. This will be the position mix and the value. Yeah, so the value is what we pass to the setting. Yeah. So this is done. This is done. And let's see. Okay, then we have another class which is file handling. Handling, and okay, this will be under different namespace, so we can, I think we can define multiple namespace. Right. Because normally you can do it in multiple classes, but multiple files, but I think that will be fine if we do it this way. Okay, so we have another namespace, and then we have the methods. So the implementation of the methods and functionality is what to this description of the user, except for the following methods which should exist in that class. So we should have the class public file handling, okay, with the file name and the path. So here I can then define my own file path, default of string, file path, or one moment I can also use the constant, which tend to be string, of course, which tend to be initialized. Okay, now maybe let's simply use the file path then. Sorry. And then I initialize the value for the file class. So the next one would be write to disk. So this would write the input contents of the file. So it will be string content, and then I do system input output. And basically I can provide this using here the system input output. So here I can use writer class, file stream and stream writer. Yeah, by the way, I need to get the stream as well. New stream. No, system. Right. So, sorry, stream here. Oh no, hold on. So we should hold on. So cut this file. Yeah, actually, I don't need the string writer in this case. And yes, in theory, I can simply use the file and write all the text here. Yeah, and that would be better. So use the file path and the content. So this would write to disk. Yeah, this would be like this, and then read from the disk would then simply read the data. That would be read from disk. So read this file path. Yeah, I prefer using this. And then this would return file read all text from file path. Okay. And then we need to create a console application method to do the tests and then test by performance error. Okay, so in this case we don't need any unit tests. Okay, so the testing is up to us, right? Okay, so the testing is up to us. We can create unit tests. So this will be the console application. Activity unit tests. So create test and reference the solution. So this is activity 8 implementation. And close this. Okay, looks that. What is this? What is this? Well, it looks this way. Okay, this is a little bit strange. I'm not sure why the class was created this way. But okay, let's maybe let me then create different. Yeah, so maybe I'll use the namespaces. So it's this namespace, and what else we have? have another namespace, which is utilities, right? For utilities, yeah. So then I create my own namespace. Utility 8. And maybe I will call my classes program. Then I create public static void main. And actually the arguments here. Alright, so and then I need to perform some tests. So I need to perform some tests. Okay, yeah. So I need to okay, let me be sure to think about it. Okay, a moment. Okay, if I want to read from the file. I mean, in theory, we can implement file, yeah, but we don't really need to read the file here. Okay, maybe this, since it's not requesting about reading file, then maybe tomorrow we will talk about how we can normally then write and read such cases, but I won't have done this tomorrow. But today, let's test how we can add elements to the collection then. So in this case, I will create the customer, some customer information here. So it will be customer, so customer 1, and the customer information, and the ID would be maybe 1. That's another name. To address, that would be, let's say, new area, something like this. And the email, just something gmail.com maybe. Okay, so let's create several customers here. So James, maybe. Let's let's just do maybe let's create 4 customers. James, what would be Jimmy, B, if one more is J John, what would be? So let's make also some adjustments here, and for the test cases, yeah, and we can add the elements to the collection. So let's create customer info collection. So create a new collection here, and I can add the elements there. So in this case, you see that I can directly assign the elements. And this is, I would say, maybe a little bit interesting point. And, oh, sorry, not this, but collection first. Because in this case, the syntax looks like we add the elements to the array, though we don't have the array here. Yeah, so we can add as many elements as we want, and this is not the case when we have the array. So, but yeah, let's implement one more thing. We want to write these elements to the file. So, but the thing is how we want to write them, or want to display them in the file. So in this case, what we need to do is we can adjust the elements there. So first of all, I want to implement toString method. So remember, toString method gives us the representation of the string of the class using the string. So in this case, I can write the information about my class. So instead ID is, so this maybe look like this. So ID, so this ID, and let's say we have the name. Is the name provided here? So then we have the address. And then we have the email. All right. So this is the visual representation of the element of the collection. But let's say we also want to provide such representation for the collection itself. So what we can do, we can simply do the same. And here we will again overwrite this, and we will print each element. So in this case, I need to use loop because I don't know how many elements there are in the collection. And remember which class we need to use. We usually use when we concatenate the strings in the loop. So we use string builder. So this goes from the system text. Maybe I can simply right here. So this will be system text str builder. And this would be new system text string builder. So for string text, but string builder. And I go through all the elements of my collection. So here I use for each. Then I use this. Oh no, hold on. Yeah, here I have not implemented the numerable, but I can do the following for the customer infos. Oh, so hold on, BBR element. And then I can add append the element to the string builder. Yeah, I can use the string, or I can simply send directly. And then at the end, I can return append, and also in addition, let's add the new line from the system environment. So, and then I return text at the end. Right, so let's see what is the result. So I want to, so we have this file handling. So I create it and I provide a file path. So let me then provide a file path. Let's add the elements here, for example. Let's add the elements here. And then I'll provide the file handling file path here. So let's add. So then the file path will be my customers.txt. Okay, so and here I can write the content to disk. So that would be I simply write the customer information collection to task 2. Okay, yeah, I can also convert it to string, obviously. All right, so let's see what we have here. Results. Okay, I need to switch to 38 tests, and then I can run. At this point, it's hard to create unit tests since we have the exception. And value is null. Okay, this is interesting. So, oh yeah, well, here's the issue. Here's the issue. My fault, sorry. Yeah, by the way, we cannot write unit tests for such. I mean, we can, but that would be complicated to write unit tests for such cases when we have the files to read or to write. And this is because yeah, I mean the unit tests by default cannot know the path to the files you have on your computers. Yeah. So that's why it's maybe a little bit complicated. So let's see, we have our customers, and yeah, so this is the result. We can print all the customers here. Yeah, so yeah, maybe we will make we'll do more work on the files starting tomorrow. Yeah, but so regarding this task, do you have any questions regarding this activity? Okay, so then, okay, if there are no questions, then these activities are done, and so we have, okay, so and yeah, so about some further plans. So we have, according to our schedule, we have the session tomorrow and on Saturday, the next week, and then with me, you're finishing on Monday 20. Yeah. So, and we have, yeah, we actually have one more knowledge check. So then it should be done then next week. Most likely then that will be on Wednesday. Yeah, and then you also have one last activity to do. It is activity 9. So let's have a closer look here. So let's have a closer look on activity 9. So this activity has two parts. One is to implement the delegate. Yeah, about the delegates, we also will talk about them tomorrow. So yeah, so we'll talk about the delegates tomorrow. And yeah, the other is to create an event for, and yeah, we'll talk about the events and delegates tomorrow. So this will be such task about them. Yeah, so yeah, maybe we'll then discuss this activity once we finish the delegate, once we go through the delegates and the events. Yeah, but we will maybe talk about them tomorrow. But I will share then this activity, and this will be until the last session. Yeah, the last session we have, or maybe I'm not sure if we. Yeah, I think we can then do this, or maybe you do this on Saturday as an option. But let's see. Maybe I'll not give any deadlines. And just activity, and yeah, most likely then you have the option to do it on Saturday. It's usually together in groups. But yeah, so this maybe I'll keep this to the next sessions. Just share the file with you so you can export it. Okay, so this is about it, and yeah, also the last knowledge check then to be next next Wednesday. Okay, so maybe I'll write it here. The last one, yeah, let's check free on Wednesday. So this is the next Wednesday, the December 15th. Just to remember. Okay, so this is about the plans. Okay, so right now, do you have any questions?
Yeah, hello.
Yeah.
I remembered one question I wanted to ask regarding activity 8.
Yeah.
I wanted to ask regarding, as I understood, it's possible to use linked list. Was it possible also to use array, for example?
You mean the simple array?
Yeah.
Yeah. I mean the simple array. The problem is, you remember. Yeah, we can use array, but then we need to implement. We simply can, if we want to use the array, then we can simply copy paste the logic from array store we had.
Mm-hmm.
So in that case, yeah, if we want to use the array, then we, yeah, for plus minus, we need to simply copy paste the logic we have here. But the thing is that we already implemented these cases. So as an alternative, we can also use the array store. Yeah, we implemented before and use this here. But I mean, on practice, we usually use the collections. We should use the generic, yeah. We usually use generic collections. It's the list. List, I would say, is the most simple way how to implement the collections. Yeah, I would say technically it's the most simple way.
I will just explain, because we had how to say dilemma what to use, and I remember the previous time I asked you regarding list, and we didn't pick simple list because you told that in list all the variables should be the same, but in this case we have 3 strings and 1 integer.
No, we have.
No.
No, we have custom. Where do we have the strings?
No, I mean in program.
Yeah.
First class customer info, the ID is integer.
But but the type is customer info. So basically, we wrap them inside the customer info. So customer info itself, this is the type.
So we actually shouldn't be bothered regarding this integer strings and something, because it's already something one.
The thing is that the type is customer info. So the collection stores the objects with the type customer info. So the type customer info is the same for all of them.
Mm-hmm. So basically,
yeah.
So basically, member of the list or array are just customers. It's not like
yes,
each
correct.
separate.
Yeah. Okay. They are. So yeah, basically the objects. This is what we're talking about. We have the objects. The objects are the information of the objects is wrapped inside them. So yeah, basically they are wrapped inside. Yeah.
Okay. Yeah. Okay. Thank you.
Okay. Good. Any other questions? Okay. Then I think for today we're pretty much then finished. So I wanted to go all these activities. So then, yeah, for tomorrow, I want to talk about the delegates and events. So we will go through the theory about them, and yeah, then so we have some more lessons. So the plan for the coming lessons would be that I want to cover some files, some file reading, writing, so JSON files, maybe we take them XML, and also the CSV files, and so most likely next week, I think if we have time, I would also maybe like to introduce you a little bit of web development. So this is just an additional topic, but web development, so some basic concepts of web development, basic things to use. Yeah, basically I will I will introduce you a little bit in HTML, CSS, and JavaScript. Yeah, so, but let's see if we can. I hope we have time then next week, and maybe also on Saturday we can then start these things. I hope we have time. And yeah, in addition, if you have any topics, any cases, any special things you are not sure about, you want to discuss, you can also then let me know. We can then discuss during the next sessions. All right, but yeah, so let me know about these topics. Okay, do you have any more questions? So if not, then I think today we can finish a little bit earlier, yes, since we covered all the topics wanted to cover today. And then tomorrow we'll talk about the events and delegates. Okay, so then thank you very much for your attention today, and see you all tomorrow. Bye.
Thank you. Have a nice evening.
Have a nice evening.
Thank you. Goodbye.
Bye bye.
Bye.
Bye bye.